Okay, these are solutions to 2023 CCEA's Mathematics AS2, so which is the Applied Mathematics module, so it has mechanics and statistics in it. Okay, first question, let's get started. First question says a constant force F newtons acts on a particle P. Time t equals 0 seconds. The velocity of P is 6I minus 8J meters per second. Find the initial speed. So when t is equal to 0, so initially, your initial velocity is 6I minus 8J. To find the speed, speed is just the size of that. So square the 6 and square the minus 8 and then square root it. And you will get 10, and that's going to be meters per second. So I don't know why they give us a whole page here to do this. It gives far too much space, so that's possibly confuse people. Okay, next bit says the mass of P is 5 kilograms. When T is equal to 4, it has a displacement of 40I plus 8J from its initial position. Find F given the answer in the form A vector I plus B vector J. So your initial velocity, remember, we found it to be, it was 6I minus 8J. They told us that in the question actually. Our time is equal to 4. Our displacement is equal to 40I plus 8J. And what we want to do is we want to find our acceleration. And the reason we want to find our acceleration is because eventually we're going to find the force and you know the mass. And remember, force is equal to mass times acceleration. So we're going to use S is equal to UT plus a half AT squared, where the S, U, and T are all vectors. And then fill in what you know. So you know the S is 40I plus 8J. Your U times your T, that's going to be 4 times your U, which was 6I minus 8J. And a half times the T squared. The T squared, remember, is 4. So T is 4. Square the 4, you'll get 16. And multiply that by a half, you'll get 8. So that's 8 times your A. Let's just tidy this up a wee bit. A bit of a mess here. That's going to be 40I plus 8J. Over here, you're going to have 24I minus 32J plus 8A. Bring the 24I across and take it away from the 40I. You'll get 16I. Bring the 32 across and add it. You'll have 40J is equal to 8A. So that works out nicely. Your A works out to B. Divide those are both divisible by 2, so 4I plus 5J, that's your A, and that's going to be meters per second squared. Your force then, F is equal to MA, so in this case, your F is just equal to 5 was your mass I told you in the question, times 2I plus 5J, and just do that out, and they wanted it in this form, so 10I plus 25J, and that's going to be newtons. Okay, next question says, below shows a hanging basket which is suspended by 2 strings. The strings are attached to 2 fixed points on the same horizontal level. It says mass of the basket is 2 kilograms. By modelling this as a particle, draw a diagram showing all the forces. Okay, right, I'll leave that one there and I'll just draw that again. Okay, it was mass 2 kilograms, so 2 newtons going this way. I'll call that tension 1, T subscript 1, tension 2. And then by alternate angles, if we just do them in there so we can see, that's going to be 60, that's going to be 30. So we'll just zoom in on our thing then. That is 60 degrees and 30 degrees. So that's what you've got. Next thing says, find the tension in this string. Tension in each string, that's what it says in the next bit. So we're going to go back and forward to this. Right, I'm just going to blank this out. So I would obviously do this in the exam in the correct place, but just so it's easier for us to see, I'll just do it in here so we can actually see what we're doing here. So finding this tension, so we can see the diagram. So here, to find the tension, the only things you can do here are resolving vertically and resolving horizontally. So if I resolve vertically, going up, I've got T1 sine, and then I'll go vertically going up this way. So it's going to be sine 60 also. I've got T2 sine 30, and that's equal to 2G, dot, 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 call that equation 1. I'll be coming back to that very soon. Resolve horizontally. My force is right equal my force is left. So force left is T1 cos 60, and going to the right, I've got T2 cos 30. And that's my equation 2, and I'm going to play with that in a second. So T1 then will be equal to T2 cos 30 divided by cos of 60. So which means, and you can fire that into your calculator, that will come out as root 3 times T2. So we're going to sub that into equation 1. So sub into equation 1. Sub it into equation 1. Instead of writing T1, you're going to write root 3 times T2 times sine of 60 plus T2 sine of 30 is equal to 2g. And I'm now going to write the g is 9.8. 2 times 9.8 is 19.6. So if you sort that out again, root 3 times sine 60, that is going to give you 1.5 T2. Sine 30 is going to give you 0.5 T2 is equal to 19.6. So what you get is 2 T2 is equal to 19.6. Sorry, let me get a bit more space here. And then that gets you, then your T2 is equal to 19.6 divided by 2, which is going to be 9.8. Then put that back into this equation. Your T1 then is equal to root 3 times 9.8. The perfect answer for T1 is 49 root 3 over 5, or it is, if you work it out, it's 16.974 dot dot dot. Set on the front of the paper 3 sig figs. So the 3 sig figs, that's what it is, 17.0 newtons to 3 sig figs. So you've got your T2 was 9.8, bang on 9.8, and your T1 rounded to 3 sig figs is 17.0. Next part of the question, so that was that one, that was 6 marks for that one. Next part says, state one further assumption you've made. So something like strings are light and inextensible. Okay, next one. Water is poured into the hanging basket. What effect will that have? The answers to part 2. Your part 2 was your tensions. It's gonna make the tensions increase. There's gonna be more weight in the basket, so the tensions in the string will have to increase. So tensions in the string, will increase. Happy days. Right, next one. What's this? Velocity time graph. As car is traveling along a straight horizontal road, its initial velocity is 15 meters per second. For the first 5 seconds of motion, it accelerates uniformly at 2 meters per second squared. For the next t seconds, it travels at a constant velocity of v meters per second. The car then decelerates uniformly and comes to rest. The total time for the journey is 60. Sketch this. So, if we sketch this, you've got your velocity on the vertical. You've got your time on the horizontal. It starts at 15. It goes for 5 seconds, accelerating at 2 meters per second squared. So it goes up to a speed, and they just want us to write it as v at this stage. It goes there for t seconds, and then it goes down, decelerates, and it does that in 60 seconds. So we've no idea if this is drawn accurately. It is just a sketch. But this time here would be t plus 5. Put that in, that helps. Okay, next part of the question, we'll come back to this very quickly. It says the total distance travelled by the car is 1 kilometre. Find t. So first thing I want to do is I want to find my v. So v is equal to, it started at 15 meters per second, and it accelerated at 2 meters per second squared for 5 seconds, which means 2 meters per second squared means your velocity is increasing at 2 meters per second. That's what that means. If you understand those units, it makes it a lot easier. So if you've gone for 5 seconds, your speed has increased by 2 by 5. So it's going to be 15 plus 10. So my v is equal to 25 meters per second. And we'll go back and we'll look at this velocity time graph. So this thing, we now know this is 25, which makes it easier. We're going to find area 1, area 2, and area 3. And the total of these things, area 1, area 2, and area 3, is 1 kilometre or 1,000 metres. So we're going to work with those. So I'm just going to do the working out for this just because we can't see the thing here. So my area 1, it's a trapezium. A half times A plus B. My parallel sides are 15 plus 25. And my perpendicular distance between them is 5. fire that into your calculator, you will get 100 meters. My area 2 is the height of it is 25 and the width of it is t, so it's 25t. That's all we can do. Our area 3, tricky enough, it's a half times the base. The base of it is going to be 60 minus t plus 5, and the height of it is now 25. If you do that out, a half times 60 times 2, sorry, I've skipped a step then. Sort this out inside the brackets, going to be 55 minus t, and then multiply in by the 25. So half times 55 times 25 will give you 687.5. And then half times the minus t times 25 is minus 12.5 t. Now we know these three areas, again, this is just so we can see it here. I'm going to get rid of all of this, just so I can do this all here. And we know the areas then are equal to, three areas are equal to 1 kilometre, which is 1,000 metres. So 1,000 is equal to 100, area 1, 25t, that's my area 2, 687.5, that's my area, sorry, minus 12.5t, that's my area 3. That's a mess, something's a mess, you tidy it up. That's going to be 787.5 plus 12.5t. Bring that across to the other side and it subtracts. So you bring it across and you subtract, you will have 212.5 is equal to 12.5t, and then divide across by the 12.5, you'll get 17 seconds. Okay, so that's what we would have had in there for 7 marks, but just so I could have seen it. Right, next question. I think this is the last of our, mechanics questions, and then we're on to statistics. It says in this one, this figure shows two small blocks, P and Q, of masses of 4 and 5 respectively. The blocks are connected by a light in an inelastic string, which pass over a smooth pulley fixed on the top of a plane. P lies on a rough plane inclined to the horizontal at an angle alpha, where alpha is equal to 3 over 5. Sine alpha is equal to 3 over 5. Q hangs freely below the pulley with a string taut that's pulled tight. The coefficient of friction between P and the plane is 1/4. And it says, find the acceleration of the blocks. Okay, first of all, let's mark on, this one was 5 kilograms, so 5g newtons. You've got T going here, tension here, tension here. You'll have a normal reaction here. And the weight is going vertically down here. It was 4g newtons. And this angle here is going to be alpha. Right, if this thing moves, of course it's going to move this way. It's going to accelerate this way, which means it's going to accelerate up the way, which means friction. So figure that out first. That means friction has to act down the way. Coefficient of friction is 1 over 4. So mu r is going down this way. So that's your diagram. Okay, and that's everything marked on. I'm also going to mark on, it mentions this, that sine of alpha is 3 over 5. So sine alpha is equal to 3 over 5. That means 3, that's 5. By Pythagoras, that has to be 4, which means cos of alpha is 4 over 5. So it's really nice when they work this out. So don't actually work out the angle. You've absolutely no need to. Right, I'm going to say consider the whole system. And I'm also going to use F equals ma. Now, the pulling force that's getting me going is the 5g. What's going against it is this t. What's going for it is this t. And also what's going against it is the quarter r. So we'll need to work that r out. And also, if you imagine this weight, once it's pulled round to here, there's a certain amount of that weight is going to be acting down this slope. So this is just me doing my forces. So the force that's getting me going is 5g. Going against that is t. Going forward is t. Going against it is a quarter r. Also, what's going against it is 4g sine alpha. And my total mass is 9. And my acceleration is a. So that's the nicest, easiest way of doing that. So we're just going to fill this all in. So it's a mess. We'll tidy this up first, will we? What do we do? We will tidy it. Well, no. We need to find the r. We'll call that equation 1. We need to find the r. So I'm going to resolve perpendicular to your plane, and we're looking just, we're looking just here. So I'm looking in this direction here. So I've got a force going up here, which is my R. I've got a force going this way. So going perpendicular to your plane, you've got your R is equal to, it's going to be 4G cos alpha. So that's 4 times G times the cos alpha. Cos alpha, what was that, 4 over 5? So that's going to be 16G over 5. Perfect. Leave it as that at the minute. Okay, and then we're going to sub into equation 1. So your equation 1 now becomes, we've got 5G, the T's cancel out, then you've got a quarter times your R. So I'll just write that down as a quarter, showing all my working out, times 16G over 5, then minus 4G times my sine alpha, sorry, which is 4 over 5, and that was equal to 9A. That all works out, multiply out and tidy out the left-hand side, you'll have 9G over 5 is equal to 9A, which then works out to be that your A is equal to G over 5, and A then, that's 9.8 divided by 5 is 1.96 meters per second squared. So that's what we've got. Okay, they had a whole page for us to do that, but just so we get, I squeezed that all in there so we could see it and it with the diagram. So there we have it, all in the entirety of that part of the question. Okay, right. It says the string breaks when P and Q are moving with a speed of 2.94. So it must be too much for the whole thing to take on the string breaks. Assuming that P does not reach a pulley, find the further time that elapses between the string breaking and P coming to rest. Okay, right, I'm going to draw a diagram again for this one. There you've got the P was going at alpha when, remember, sine alpha was equal to 3 over 5. Was it 3 over 5? It was 3 over 5. And the weight, or the mass of P was 4. So that's 4G newtons. That's alpha. You still had your normal reaction. It's moving this direction. It's going to be slowing down. The string is slack now, so I just do a wee wiggly line then to show that. That's they're the only forces that are acting. You've got your friction there, sorry. And that's it. So I'm going to use resolve parallel to the plane, going upwards, so treating upwards as positive, and I'm using F equals ma. So I like to go, I know my acceleration is going to be negative here, but I like to put the acceleration angle arrow in the direction that the thing's actually moving. It is going to work out to be negative here. And up the plane, I have got the minus 1/4 r, because that's actually going down the plane, and I've also got the 4G sine alpha, and that's equal to my mass, which is now 4, because it's just this thing, times my acceleration. So fire all of those things in, and with a fair bit to do in this question. That's going to be minus 1/4. What was my R? We had a R worked out from earlier on. It was 16G over 5. Perfect. Minus 4G times my sine theta, which was 3 over 5. That's equal to 4A. So that works out to be minus 16G over 5 is equal to 4A, which works out that my A is equal to minus 4G over 5, which works out to be minus 7.84 meters per second squared. That's my acceleration. Okay, fair bit to do here in this one. I'll have to squeeze this in. My U is equal to, my initial speed, it told you in the question, was 2.94. My acceleration I now know is minus 7.84. When I come to rest, my velocity is 0 at rest. And what we want to find is our time. So we're going to use V is equal to U plus AT and just fill in 0 is equal to 2.94. 2.94, then minus 7.84 T. So that's 7.84 T is equal to 2.94. And then your T is 2.94 divided by 7.84. And what you're looking for then is 0.375 seconds. Okay, that is the end of that section. We're now on to section B. Section B, what is section B? It's our statistics section. It says explain the difference between the terms population and sample. Okay, so population, something along the lines of this. So population is everything or everyone. Okay, being investigated or something like that. So everyone being investigated, being looked at. But a sample, it's not possible to look at everyone, so a sample is a number, say, or selection of people or items of people or items from the population. Okay, so nobody likes these sort of waffly questions, but there we are. Next one. In a large holiday resort, 50% of the hotels are 5-star, 15% are 5-star, 55% are 4-star, and the remaining hotels are 3-star. Researcher wishes to estimate the average price of an overnight stay in a hotel in a holiday resort using the prices from a sample of hotels. Explain why a simple random sample may not be appropriate. So if you do a random sample, what might happen is you might pick everybody from these 4 stars and nobody from the cheaper ones, nobody from the more expensive ones of 5-star and nobody from the 3-star. So potentially you could get everyone from the one thing if you're just randomly picking people. So explain why it's not appropriate, and just say it's because potentially you might not get anyone from one of the groups and people in different groups pay different prices. I'm spelling different incorrectly. Different prices. Okay, so what would be better would be a stratified sample. Would be better. The reason is so you're getting, you're selecting people in the same proportion as they are in the population. Okay, so something along those lines. Right. Next question. Next question says, on 2 successive Saturdays, the length of stay by vehicles at a shopping centre car park were recorded. The histogram in figure 3 below shows a length of stay in minutes by 150 vehicles on the first Saturday. It says, show that the mean length of the stay is exactly 1 hour. Right, we're now going to have an x values and the corresponding frequencies in, and then we're going to use the statistics function in the calculator. The x values are the midpoints of all these. That's what the x values are going to be. That's what we're going to have to assume it to be. So they're going to be 15, 45, 75, 105, and 150. To get the frequencies, frequency is your frequency density times your width. Okay, and just be careful, I made a mistake originally on one of these when I did this out. That is 0.9, so 0.9 times 30 works out to be 27. This one is 1.8 times the 30, and that works out to be 54. And then this one is 1.5 times 30, works out to be 45. This one is 0.6 times 30, and that works out to be 18. And this one is 60 times 0.1, which works out to be 6. So there you've got your frequencies, and we can just put them into our table now. So what were they? 25, 54, 45, 18, and 6. Okay, put those into your table on your calculator, on the stats mode in the calculator, and then from the calculator, and really that's the way they want you to do it. You can get your sigma f, which is 150, and you knew in the question 150, so I put them in incorrectly because I got this first one up here wrong. So that's how I knew I made a mistake, because I had got 147, I think I had my first time, so I knew it should have been 150, so I went back and checked it. My sigma fx is 9,000, and when you're using your calculator, you must show these things. Your x bar, then all they want you to do then, and you can get that from your calculator, is 60, and that was in minutes, which of course then is 1 hour, so you know you're right. Okay, next part of the question says calculate the variance. Again, from your calculator, just write down what you've got from your calculator. Your sigma f was 150, sigma fx, it was 9,000, sigma fx squared, it worked out to be 702,000, and then what they're testing here is that you know that you use the lowercase sigma x in, and then that is 32.86335 ... but therefore your variance is that thing squared, which works out really nicely to be 1,080. Okay, really didn't like this next question. It says, for the second Saturday, the standard deviation for the length of stay was 26.1. So remember in our previous one, the standard deviation was 32. So in this second Saturday, the standard deviation is smaller. So last thing here we're going to do in this question, it says, just say the standard deviation is smaller, indicating the times have less variation. Okay, that's all we can say really, but for 3 marks I'm thinking that maybe want something else and just say we do not know the mean of the second Saturday. So do not know then if people have spent more or less time. So I've stayed for longer or shorter. Okay, so it's a bit of an annoying question. I don't know what they're wanting really for 3 marks, but I'd imagine it's just more than just saying that the variation is smaller. So that's it. Okay, in question 7 it says, from past experience, an estate agent estimates the probability of a client making an offer to buy a property after viewing is 0.45. Tree diagram shows the possible outcomes after 2 clients have viewed a property, and B is the event that a client makes an offer to buy. So not B then is obviously they don't make an offer. Show that the probability that just one client makes an offer for a property is 0.495. So 1 could be this one makes an offer, this one doesn't, or this one doesn't and this one does. So those 2 options. So you have 0.45 times 0.55 or 0.55 times 0.45, and when you do that out you will get 0.495. Okay, it says the estate agent wishes to use a probability distribution to model the number of offers received after a property has been viewed by 20 clients. Write down the name of the probability distribution which the estate agent could use and explain fully why it is appropriate. Okay, so it is binomial first of all, and why it is binomial has success or failure. You've always got 2 possible outcomes. So in this case, i.e. you make an offer or not, Also, there's a finite number of trials. So in this case, i.e. you've got 20 trials because there's 20 people, 20 clients. And the last one then, they are independent events. So the three things for binomial is there's success or failure, which means two possible outcomes, finite number of trials, and independent events. Okay, and so what really that means, one person makes an offer, has no impact on another making an offer. Okay, let's go far on to the questions on these then. Using probability distribution, you identify in part 2, calculate the probability that exactly 10 offers will be received. Okay, binomial is X is distributed with an N, your number of trials, and P is your probability of success. In this case, X is distributed as binomial. 20 was the number of trials, success was 0.45. And we want to find the probability that X is equal to 10. 10 offers are received. So we're going to use, and there's another way of doing this, but I'm only going to show you one way. We're going to use on the Casio Class Whiz calculator, we're going to use a binomial PD. And in it, you put in your X is 10, your N, I think they read it as capital N, is 20, and your P is 0.45. And you fire that into your calculator, and probably X equals 10, then it gives you 0.159, and that's the 3 sig figs. Next one says fewer than 5 offers are received. So really, fewer than 5 offers, that means X is less than 5, and that is the same as X is less than or equal to 4. So then we're going to use the binomial CD. So X is 4. So binomial CD stands for the cumulative distribution. So X is 4. Always has to be in this form for you to use it. So less than or equal to, that's why I modified that. N is 20. And your P is the same thing, 0.45. And when you work it out, that gives you, fire those in, that will give you 0.01886. So the 3 sig figs, 0.0189. All right. So the last question then for us to do, we have got, last question for us to do then says events X and Y are such that probability of X is equal to probability of not X and not Y. And this thing, I get very confused with these. This is, if you imagine you've got a Venn diagram, this isn't quite what this Venn diagram looks like. I'll tell you why in a wee second. But this bit is a wee bit outside, so it's not X and it's not Y. So it's everything outside the union. Okay? So that's what you've got. So it's everything outside the union. And that's what you've got all of these things. It also tells you they are mutually exclusive. So that tells you probably X and Y is equal to 0. So I am sure this isn't the most efficient way I've done this. It seemed to be quite an awkward way of doing it, but it works. So I'm just going to write down their formula again. Probability X is equal to probability not X and not Y, and is equal to 1/3 the probability of Y. And also, what do we know? Probability of X is equal to 1 minus we'll go over this again. Sorry, the probability, we know that is then probability of X then is equal to, we're going to change this middle bit, that's 1 minus the probability of X union Y. So that's what that middle bit is. Okay, so we're forgetting about the Y at the minute. So that's probability of X is equal to 1 minus, and we'll do this in a square bracket, probability of X union Y is probability of X plus the probability of Y minus the intersection. And then that, we'll just tidy it up, that's probability of X is equal to 1 minus the probability of X minus the probability of Y, and then that would be plus 0, because that thing is 0. Just bring all the X, probability of X's to one side, you'll have 2 probability of X's is equal to 1 minus the probability of Y. And what else do we know? Where have I got to then? We'll bring that 2 across, and it becomes a half. So a half times 1 is a half, and then minus a half times your probability of Y. Okay, so this is why I think I haven't done this the way they had intended me to do it, but it still will work. We also know that this thing, probability of X is equal to 1/3 probability of Y. So I'm sort of finding it in the wrong order here, but it doesn't really matter. So we've got a half minus that. Oops. So if we bring all the y's together again, bring them all over to one side, we'll have a third probability of y plus a half probability of y is equal to a half. So that is 5/6, 5 over 6 times the probability of y is equal to a half, which means the probability of y is equal to a half divided by 5 over 6, which means your probability of y works out to be 3 over 5. And therefore, your probability of x, it was 1/3 times your probability of y, remember, which is going to be 1/3 times 3/5, which is going to be 1 over 5. Okay, last two questions for us here. It says, show that x and y are exhaustive events. You're going to look at the probability of x union y, because it will be 1 if they're exhaustive. So probability of x, probability of y, we're showing that they're not exhaustive. So that was 1/5 plus 3/5 and then minus 0, which is 4 over 5, which is not equal to 1, so not exhaustive as we had wanted. And the last one, explain why x and y cannot be independent. If two things are independent, then the probability of x and y is equal to probability of x times the probability of y. So let's just work out what the probability of x times the probability of y is. It would be 1 over 5 times 3 over 5, which would be 3 over 25. But we know that the probability of x and y, they were told they were mutually exclusive, so x and y cannot happen at the same time. So that means, therefore, the probability of x and y is not equal to the probability of x times the probability of y, which means, so they are not independent. And that is us done.